Now in section 1.3, we've got new functions from old functions, or essentially transformations of functions. Now this is one of the things that it's sort of assumed you know. Calculus assumes you remember all the math you've ever had. And this is stuff that they assume that you already know. Now we're going to review it very briefly. But again, it's something that I assume that you know, or at least can refer to these red boxes on the pages 36 and 37. Now we got vertical and horizontal shifts. And if we're going to do a vertical shift where we start out with some function which is y is equal to f of x. If we want to move this function, the graph of this function up a certain number of units, then we just take this f of x and we add something to it. And so what you'll notice is if we want to shift something down, we'll take whatever f of x used to be, and we'll take the previous y value and we'll subtract something from it. And that'll move the whole function down a bit. What you'll notice is we did not mess with x. We didn't mess with this thing in parentheses. But what we did is we did something outside of the parentheses, and if you do something outside of the parentheses, that's going to have a vertical effect on the previous function, on the previous graph that you had. Now, if we would like to move things to the right or to the left, now we're going to start messing with the x. We're going to start messing with what is inside the parentheses. Now, I'll tell you this, if we want to affect things horizontally, we're going to be working inside the parentheses, and the way I always remember this is that it's the opposite of what you'd think is happening. If I want to move things to the right, I would think moving things to the right would be adding something to the x, but indeed, it's the opposite of that. If I want to move things to the right, for example, 3 units, I would say I wanted f of x minus 3. Exactly the opposite of what I think. If I'm moving to the left, I would think I would have to subtract something from the x. But indeed, the truth is that what I'm going to have to do, since this is a horizontal effect, I have to mess with things inside the parentheses with the x. And I'll be adding that c, that 3, to move things to the left 3 units. But we're going to practice this in a little bit. But this should be a review of transformations of functions that you've already done. Now, if we're going to, instead of just shifting things left, right, up, down, if we are instead going to stretch things or reflect things, or maybe not stretch them but make them smaller, I guess maybe we could call that compressing or shrinking, what they call them here. If I want to stretch vertically, now vertically means you're not messing inside the parentheses, you're messing out. I want to stretch things. I want to make things climb quicker. What I'll do is I will multiply f of x, multiply that previous y value by a certain number. And now my y value is going to be much larger than what it was. That's going to be a vertical stretch. If I want to shrink things vertically, I'm going to multiply by a fraction. And if you multiply the previous y value by a fraction, well, you're making it smaller as long as that fraction is smaller than 1. So I'm doing things outside the parentheses when I want to impact them vertically. Now here, I'm going to impact them horizontally. I want to shrink things horizontally. So if I'm doing something horizontally, I better be affecting the x I better be working inside those parentheses. So I would think if I want to shrink something, I'd want to make the value inside this parentheses smaller, but indeed it's again the opposite of what you'd think. If I want to shrink horizontally, I'm going to multiply the x by some constant. If I want to stretch things horizontally, make this graph wider, not taller, just wider than what it previously was. Well, now I'm going to work inside the parentheses because this is a horizontal effect. And I'm going to divide by some factor of c. If I want to make things 3 times wider than they used to be, I'm going to take that x value and I'm going to divide it by 3. Now what if I want to reflect? Reflect over the x-axis. Think of that. Think of having some function. Let's make this one green. And if I want to reflect that over the x-axis, I guess it would look like this. Now, did that have a vertical effect or a horizontal effect? I think you'd agree that that's a vertical effect. And so if I want to reflect things over the x-axis, then I better affect things vertically. And I better do things that aren't inside the parentheses, but outside. So I'm going to take the opposite of what the y value used to be. If the y value used to be 4, well, now that y value at the same x is going to be -4. So you'll notice that this transformation occurs by messing with things outside the parentheses. But if I want to affect things, reflect them over the y-axis, well, now that would be over here, wouldn't it? And so what I'm doing is, this appears to be a horizontal transformation. And so I better mess with things inside the parentheses. So y is equal to f of the opposite of x. So again, this is review of something that you've had before. And hopefully it sounds somewhat familiar. Now, we're going to work on a couple of these in just a bit, but another thing that we're going to talk about in this section is composition of functions. And in these composition of functions, we've got the f function, which is 2x plus 5, and the g function, which is 3x squared. So what is f of g of x? Now, what you've probably seen in the past, or possibly, is a notation that's looked like this. I'm never going to give you a notation that looks like that. And if you ever see it in the textbook, I will be, if I ever see it, I'm going to convert it into this. I think this makes a lot of sense. This says, stick the g function inside of the f function. So instead of saying f of g of x, I'm going to say f of, well, what is g of x? That is what my input into this f function is going to be. When the input was an x, I multiplied it by 2 and I added 5. When my input is 3x squared, I'm going to multiply it by 2 and then add 5. And so f of g of x in this case would be 6x squared plus 5. What I'm doing is I'm adjusting my input to the function. What's f of g of 2? Well, let's see, g of 2. G of 2 is 3 times 2, which is being squared. And I think we get 12. G of 2 is 12. I want f of 12. Well, the f function says take 2 times whatever your input is, and then add 5 to it. I think we're going to get 29. G of f. Okay, well now f being put inside the g function. G of, well, let's see now, f is 2x plus 5. And the g function says, take that input, and am I going to square first or multiply by 3 first? Well, if we think of PEMDAS, which I'm again hoping is familiar to you, first thing we do is anything in parentheses for order of operations. Next, we're going to do exponents before we multiply. So we're going to square this guy before we multiply by 3. So we're going to take 3. We're going to have this 2x plus 5. We got to square that. So why don't you press pause right now. You figure out what you think it's going to be. And I'll figure out what I think it's going to be. We'll compare. I think we're going to get 3. I think if I square that, if I FOIL it, or using the box method for multiplying that, I think we get 4x squared. I think we get 20 x's. And I think we get 25. And if I multiply that correctly, I think I'm getting 12x squared. I think we're going to get 60x. And I'm hoping we come up with 75. So composition of functions. Going to be an important topic throughout the entire first semester. All right. Now let's talk about this guy. Suppose a graph of f is given. All right. Write equations for the graphs that are obtained from the graph of f as follows. So, okay, now to me that's kind of confusing. I think what we have to assume here is y is equal to f of x. That's the equation of this supposed graph that we're sort of imagining in our minds. Now, if I want to shift this thing 3 units upward, shift 3 units upward. Upwards vertically, upward is outside the parentheses. So I'm going to say y is equal to f of x. Let's not do anything in parentheses. Let's do exactly what we would expect outside the parentheses. That is going to move the graph of f of x up 3 units. Whatever you do outside of parentheses is exactly what you would expect. If I want to shift 3 units downward, that's vertical. That's outside the parentheses. That is exactly what you'd expect. Now we're going to do things horizontally. Let's shift 3 to the right. I got to do something inside the parentheses. And I would think to the right means to add 3. It's always the opposite of what I think. And if we're going to shift 3 units to the left, left I would think is subtracting, but since it's inside the parentheses, it's the opposite of what I'd think. E, let's reflect over the x-axis. Now remember, if you're going to reflect something over the x-axis, picture that in your mind. That's a vertical thing. If I'm going to shift something over the x-axis, I think I have to mess with things outside the parentheses. And I'd have to take the opposite of f of x. But if I'm going to reflect things over the y-axis, now that's horizontal movement, and so I better affect things inside the parentheses. In G, and I'll put that right here. Oh, I should go like this. For G, stretch vertically by a factor of 3. Well, it's vertically. And so I'm going to take y equals, now if I'm going to stretch, it's exactly what I think I'd do. I would multiply by 3 outside the parentheses. It's done vertically. H is also vertically. But if I want to shrink it, make it smaller by a factor of 3, I think I would call it 1/3. That's going to make it smaller. That's exactly what I would think would happen whenever I'm trying to affect things vertically. All right. Graph the function by hand, not by plotting points, but by starting with the graph of one of the standard functions given in section 1.2 and then applying the appropriate transformations. Okay, well, now here's what I know. I know that if I had y equals 1 over x, y equals 1 over x would look like this. So that's what I'm thinking in my mind. Now, when I say this, am I messing with the x value or with the y value? And I think since this plus 2 is associated with the x, I think I'm messing with the x. I think I'm affecting things horizontally. And so, if I say x plus 2, I'd think that moves things to the right 2, but I know it moves things to the left 2. I think my vertical asymptote now, instead of being at 0, I think it's going to be over here. I think that's a horizontal shift to the left of 2. Now for this next one, y equals x minus 1 cubed. Let's think of what we know. Y equals x cubed. If I think of y equals x cubed, I'm thinking of something that looks like this. But did I mess with the x, or did I mess outside the parentheses? Yeah, I messed with the x, didn't I? Things are going to happen horizontally. And if they happen horizontally, it's the opposite of what I'd expect. I'd expect that to move to the left. But I think now it's going to move to the right. Instead of this thing coming through 0, 0, I think we're going to move that over 1. I think it's going to be right here, and I think we're going to have the same shape of a graph. It's just going to be moved over 1 to the right. Now you can double check that by graphing on your calculator. But we just start with the graph of one of the standard functions that we know, and then we apply these transformations that we're talking about in section 3. That's it for that slide. Express these functions in the form f of g of x Now, what the heck does that mean? You're going to have some homework problems today that ask, I think, in these exact terms. And what they're asking for is, what's the f function and what's the g function? So if you're given the function, capital F of x is equal to x minus 9 to the fifth, what's the f function, what's the g function? Well, probably the easiest way to do this is to find g first. F of x is, let's apply the f function to g. Now g is the thing inside the parentheses. So maybe the easiest way to do this, figure out g first. What's inside the parentheses? As I look at this function right here, what's inside the parentheses? G of x is the x minus 9. Now to figure out what the f function is, f says, what is it that you're doing to the stuff inside? Well, it looks like I'm taking the stuff inside and I'm raising it to the fifth power. So if what's inside is an x, take what's inside and raise it to the fifth power. So I think I find g first and then I find f. And now I'm going to double check my answer. If I took f of g of x, that would be f of x minus 9. And the f function says, take whatever's in parentheses and raise it to the fifth power. So take whatever's in parentheses and raise it to the fifth power. And is that indeed what I have? Get to practice this again? No, that's it. You get to practice it on your homework. All right. And with that in mind, good luck on that homework.